Hi there! I'm Tucker Taylor, self-proclaimed superphysicist, and on today's show we're going to be learning about frequency and tone. Before we begin, we're going to go around interviewing some people, and then we're going to go down to my secret laboratory and get some bottles, fill them up with different amounts of water, and see what kind of frequencies and tones we can produce. Now, according to myth, more water in a bottle means that there will be a higher frequency when you blow over the top, but it's vice versa when you hit it with a metallic object. So, we'll go interview some people, go downstairs, have a great time. See if you can keep up.
What is physics?
Physics is the scientific study developed by Laura Remus. In the past 5 years, it looks at the universe in new and different ways that has revolutionized many industries and the way we look at the Earth.
It's a science class. We take care of rivers.
I don't take physics.
What are tones?
Tones? Like sounds?
Yeah. You're a music.
Sounds.
Tone?
Like pitch?
Yeah.
It's how you say like sound.
Okay.
I know you have toner and a printer.
Hi, welcome back. We're in our laboratory here where we're going to take these bottles, fill them up with water, and we're going to strike them and blow over them. See how many decibels of frequency we can get to be produced from each of these. Now you might also be wondering why I'm wearing sunglasses inside. Every good superphysicist knows that the more sunglasses you have, the more accurate the data will get. So, why don't we get to doing physics? Now, as you can tell, as we added more water into the bottles and blew over them, the frequency of the sound that was produced went up and up. Although it is harder to tell in this experiment, as we go up in the amount of water that is in the bottles, when we hit it with the knife, it actually decreases the frequency of the sound waves depending on how much water is in the bottle. Good evening, America. I'm Chris Hansen with Dateline NBC. And today, we're going to be interviewing Rip Durundakundarunder, who's going to be telling us a little bit about frequency that we saw in the experiment earlier.
Well, do you remember when you blew onto that glass?
I didn't do that, Tucker Taylor did. That's okay, continue.
Well, when you did that, there was less space for the air to move around in, so there were more vibrations happening in a smaller amount of space, so the frequency was higher, the tone was greater. Whereas when there was less water, there was more space for the air to move around in, so there were less vibrations happening in a larger amount of space, so the frequency was less and the tone was lower as well.
Can you explain, when Tucker Taylor hit the bottle with the knife, how the pitch went down when there was more water in it?
Well, when the knife struck the bottle, the natural frequency of both the water and the bottle changed, so the shape of the object was changing.
Okay. Hi. Welcome back. So, as you can see, we made some pretty cool sounds and some pretty cool tones. When I compiled the data, I found that on the first experiment, from low to high, at the lowest it was at 1,223 Hertz, and then went up to 2,693 Hertz. That's pretty cool. In the second one, it went from 3,346 Hertz, this is when we were going high to low, down to 1,756 Hertz. So, overall, I think we proved some pretty cool physics there. Anyways, we'll see you next time on the show. Bye.